Okay, so when you're trying to find the domain of composition of functions, the first thing that you have to do is find the domain of the inside. And then the second thing you have to do is find the domain of the composition. And your whole domain is the domain of both of these. So for example, here, if I look at these independently, the domain of 1 over the square root of v would be 0 to infinity. You can only put positives in here because it's a square root. You can't put 0 in here because it's irrational. So this would be a parenthesis 0 to infinity. The domain of h of v is all real numbers. We can put anything we want into a quadratic. So keeping both of those things in mind, the domain of m over g, well, first we have to find m over g. So that would be 1 over the square root of v over v squared minus 36. So here we have another denominator. And we know that when we say v squared minus 36 equals 0, that if we solve that, we would get 6 and negative 6. So that means the domain of this function is all real numbers except 6 and negative 6. So v can't equal 6 and negative 6. So what I have to do is take the domain of each of these and combine it with the domain of the composition. Well, all real numbers we don't need to worry about. I'm looking at only the positives and can't be 6 or negative 6. So that means that I can start at 0 and go up to 6, but not including 6. And then I can do all the numbers bigger than 6. This naturally excludes the negative 6. So we didn't need to worry about this one. So then what we say is all the positives except 6. Okay? So then the next piece of this is m of g of x, like this. So with true composition like this, the first thing, that was m of h of v. So the first thing that we worry about with composition like this is the inside function. So the domain of h of v is all real numbers. So then really we don't need to worry about it. So then let's do the composition and try to figure out the domain of that. So here we're going to take h and plug it in, and we'll say, okay, then this is 1 over the square root of, and instead of v, we put in all of h. So 1 over the square root of v squared minus 36. And so now the domain of this would be anywhere that this radicand is strictly greater than 0. It can't be 0 because it's in the denominator. It can't be less than 0 because it's under a square root. So where does v squared minus 36, where is that greater than 0? So these get a little tricky when you're dealing with the quadratics, and I'm honestly surprised it's on here because we're going to do that later on in the semester, these inequalities with quadratics. So for right now, I want you to think about what happens when you plug numbers in here. Okay? I know that if I plug in a 6, this will be 0. So it for sure can't be 6. I know that when I plug in a negative 6, this will be 0. So it can't be -6 either. What happens if I plug in a number less than -6? Like, let's think about -10. -10 squared would be 100. 100 minus 36 is okay. So the numbers less than -6 are okay. What if I try a number in between -6 and 6, like say 0? If I plug in 0, I would get 0 squared minus 36. 0 minus 36 is -36. And I can't take the square root of -36. So I would say the numbers in between are no good. But then if I plug in a number bigger than 6, 10 squared would be 100 again. And so the numbers bigger than 6 are okay. So then here, I would say that the domain is all of the numbers less than -6 and greater than 6. And I'm going to give you a hint that it's pretty much always going to look like this. So for example, if this was x squared minus 25, this would have been a -5 and this would have been a +5. And it would have looked the same as this. If this had been 144, this would have been a -12 and this would have been a +12 and it would have looked like this. Okay. So then the last kind here was when they did h of m of v. And so then we worry about the domain of the inside first. So we already know that we have a domain restriction of all the positives. Now let's do the composition. So I'm going to take this and plug it into h. So that's going to become 1 over the square root of v. Why do I keep on writing 4 instead of a v? 1 over the square root of v squared minus 36. 1 over the square root of v, and then you square it. Well, 1 squared is 1. The square root of v squared is v. And then the domain of this would just be that v can't be 0. But this domain already says v can't be 0. So this is my domain for that version of it.